In this interesting project, researchers have proposed a new way for robots to find objects in households where things get moved around. Andrei Kurenkov and his colleagues at Stanford University have introduced Node Edge Predictor. Node Edge Predictor is a model that learned to predict where objects are located in your home. A popular way to represent objects and their locations is a graph in which each node is either an object or its location and an edge connects the two. A recurrent model could predict the locations of objects using a separate graph to represent each time step, but that would require many graphs. Instead, the model can predict locations using a single graph in which each edge includes the time elapsed since the associated object was seen in the associated location. The model learns to predict the next most likely place to find an object based on the object's most recent frequent and long-standing locations. So what these researchers did was they simulated a robot looking for things in a household. First, they built a simulator of houses, object locations, and when and where they moved, and then a graph that represented a house containing objects. And thirdly, a machine learning system that predicted where objects might be found. The author then simulated this robot moving around 100 households with various floor plans. They also built a training set of around 10,000 graphs. And finally, as I said, they trained the machine learning model to predict whether an object was on in a given piece of furniture. That is, for example, whether an edge connected a given object and location at the current time step. The system embedded previously observed nodes and edges using a separate vanilla neural network for each, concatenated the embeddings and fed them to a graph neural network followed by a two-layer transformer. This new system has already been tested and their so far tests divulge that the performance is pretty cool. The baseline which they used included a random guessing, which means that always guessing the piece of furniture where the object was last seen, and also a Bayesian model that guessed whether the object was on or in a given piece of furniture. So on average, the system found the object in 3.2 attempts, while the next best model, which is Bayesian, took 3.6 attempts. This is also called as feature engineering, and it is about figuring out the best way to represent data so a model can learn from it. In this work, engineering time-related features such as time elapsed since an object was on a piece of furniture or the number of times an object was observed on a piece of furniture over time enabled a non-recurrent model to learn how graphs change over time. And I believe that the future work is going to be really groundbreaking on this one because if you go through this paper, they have also given a lot of example as how this can be accomplished and how this dynamic, how simulator algorithm works and so on and so forth. And this is the feature engineering which I was mentioning earlier. And a physical robot is likely would use object detection on its camera feed instead of a simulator that told it directly where objects were associated. So a lot of work which I believe is going to be done in this regard in the future. Let me know your thoughts or comments, or if you have seen any similar project, let me know and I'll be happy to do a video on it. But I think pretty exciting times ahead for us in terms of AI and robotics. If you like the content, please consider subscribing to the channel. Thank you very much.